Hello, this is a continuation from the last segment that we talked about, and we're going to be talking about coterminals of angles. Now let's define coterminal. Coterminals when two angles are in the standard position and have the same terminal side. Now, if you look at this here, this angle here, remember we talked about the initial side and terminal side, okay? And like here, starting from here going in this direction in a what? Clockwise motion. We stop right here, we have an angle of some sort from this point to that, going out, shooting out into the second quadrant. We have reference angles, which we will talk about in later segments. But however, this angle, this reference angle here is coterminal with angle B. So angle A and B for this matter are coterminal angles of each other. Same with here too. When you actually take an angle and start from the initial point and you go around and hit 180 and then 360 and then continue on to 450 and continuing on and on. Here you stop down in this the third quadrant. Of course, your initial angle, you want to start from the initial side to the terminal side, but to the shortest route, the terminal side of that angle, which would be better. And angle A and angle B are coterminal angles of each other. Now, because angles have the same terminal side, it follows that the values of the trigonometric functions of coterminal angles are equal. And here we have some formulas here, some expressions here that will help you in degrees and also in what? Radians. Right? K can be integer, can be any value in integer, positive or negative. And that with this here, the 360, of course, is one revolution around the circle. So this will help you calculate your coterminal angles. And we're going to do some examples of that. If we go to here, let's do a problem. Use the coterminal angles to find the exact value of the trigonometric functions, right? We have A, we got sine 390, and B, cosine 420. So let's look at this. Sine of 390 degrees, right? So we're starting from the initial side here, if you see. And what I can do is actually just work this thing here from here. Start from the initial side, it will go around and around and around and around here. That'll be what? 180, and then around, continuing on and on. This is be 360, and 390 is going to lie between 450 and this is 360. So somewhere in between in the first quadrant. So here. So then what you do, you draw your initial from the origin, your angle, and of course from the initial side, the short side, not from over here. This is actually a reference angle, but it's big, right? So this is the reference line, and you can actually draw from there to the terminal side, but it's better to go from the short side, where the initial reference line here to the actual terminal side, which is shorter, see? And so what we have here, we have an angle. We may not exactly know what that is quite yet, but but just plugging these things in of actually sine theta plus 360 K is equal to some sines, or 390. And next you can put this in. And actually what you can do to do this, since 390 degrees is much larger than 360, you can say 390 minus 360. You see this? And with 390 minus 360, what do we get? We get 30 degrees. So 30 degrees from here to there, and it's in the first quadrant, you see. So 30 degrees. Now, it's sines, you see? Sine is sine 30, because remember, we talking about sine 390 degrees, so we want to use coterminal angle to find the exact value. Now, since we're talking about a triangle, right, that has 30, 60, of course, your value of this thing will be what? 1/2. So sine 30, which is the coterminal angle, the value of it will be 1/2. And we can say that the angle 390 is coterminal with 30 degrees. Let's do another problem. Okay, so let's say cosine 420. So here we got a nice one here. Look at what we have here. Pretty much the same concept. And let me just do this with you, kind of, sort of, off to the side. Do this off to the side. You see, this is my X and Y axis, right? And so we want to know what the value of cosine 420 degrees. So starting from here, the initial reference line, the initial side, the reference line, right? And I want to go, and it's actually positive. So we're going to go, right? 90, 180, right? 270, right? 360. We're at 360 now. As we keep going at 360 now, from 360 in here, that's about 450, right? But it's going to lie somewhere, 420 is going to lie somewhere in between here and here, between this point here and this point here, actually in the first quadrant. So actually when we go here like so, it's going to lie in between, and then what do? We draw our angle. So from this point, okay, we don't want to come from this side to that side to draw an angle. We want to come from this side. And so we figure, we don't know exactly what that is, but we're going to calculate this, right? And so when we calculate this, and of course, we say that, what, 360 or 420 minus 360 degrees, and we want to subtract 360 from 420. So what would that be? So doing that, we get 60 degrees. So we get 60 degrees for this thing. So it's going to be cosine 60 degrees, just like so over here. So actually you can put it in here. You can put it in the actual formula that you see down here for cosine, and actually put 360 here. And of course we don't know what theta is, but it's always best to draw or sketch the angle. Always, I highly emphasize that. Always sketch the angle, and you can kind of add up and subtract it. But when you actually put this in, you can actually say 420 minus 360 and get an angle, the appropriate angle. But sometimes you might have to do a little bit more work than usual. So cosine 60, if you know, and you remember our triangle, our 30-60 triangle, and that we have our special, it's a special case here, where we actually have our values, and cosine is the adjacent side over the hypotenuse. So the adjacent side will be what? The adjacent side will be 1 over the hypotenuse, which is 2. So it'll be cosine 60 is equal to 1/2. Just like so right here. Just did the problem. Okay. So let's do one more problem. Let's do a problem dealing with let's pull up a chair. And we see, let's talk about secant. Secant. Secant -7 pi divided by 4. We see this. So we can use the old formula, which is pi, which is theta plus 2 pi. 2 pi meaning in radians, in degrees is 360 degrees, but in radians is 2 pi, 1 revolution. And you notice a -1 there, that's because this is a negative angle here, right? So K is -1. And so we know whatever we do from here, we need to find out what angle that goes here to get a secant of what? -7 pi over 4. So again, you can take -7 pi over 4 right here, plus, right, plus 2 pi, and actually find the common denominators. And I love to do simple math like this by hand here. A lot of people use calculators, but it's always good to know how to do things by hand. Common denominator being 4, and 4 going into 4 is 1 times. 1 times -7 pi will be -7 pi over 4 right here. And then you got 1 that goes into 4. 4 times 2 pi will be 8 pi. And then when two signs are two numbers that have different sides, you always subtract and take the sign of a larger number and put it in the result. And as in this case, right, as you rename the fraction, you see that that's the bigger number. So it's going to be pi over 4. So pi over 4 plus 2 pi here. And actually that's going to be -2 pi when you calculate this. That's going to give you the secant of -7 pi over 4. So how you read this is the secant of pi over 4 plus this will be -2 pi. It will equal to the secant of -7 pi over 4. Now, secant pi over 4 will be actually what? As you see right here, you have a 45-degree angle here in radians, right? So basically, what this will be actually is when you actually do the 45-45, right? 45-45. And it's secant. So basically, secant is one of the reciprocal identities. So if cosine is the adjacent over the hypotenuse, it'll be the hypotenuse over the adjacent. So it'll be one of these legs over the other leg, or vice versa. In this particular case, whichever, since these are the same. So it'll be 1 over 1 is equal to 1. And so secant pi over 4 will be equal to 1. So -7 pi over 4 is coterminal with pi over 4. So should we do another problem? We'll do another problem for you. Cosecant 270 degrees. What do we have? Right? So basically, cosecant -270 degrees. What do we have? Basically is when we draw from this point here, and we're going to be traveling in a clockwise direction because it's negative. And of course, when you plug 360, well, 360 is already a part of the formula, times -1, which is K, you have that value. So what number here, so don't really look at this yet, of course, what is going to make this to be, what angle here is going to, plus this, added to this, is going to give you cosecant what? 270 degrees. So here we have, that looks like an 8 there, so we just put there we go, make sure that's correct there. So what are we going to do? What we're going to do is actually do what we did, kind of do some subtracting. And so 360 degrees, and you can say minus 270, or you can say -270, or you can say -270 plus 360 degrees, either or, as long as you carry the sign with you. You're going to have, what we're going to have here, let's do the math here, by hand. That's going to be 90 degrees. So 90 degrees is put inside here as such. And then of course, whatever you get here, cosecant 90 minus 360 is going to give you cosecant negative what? 270 degrees. Now, again, for here, we can say that this angle is quadrantal. Remember we talked about quadrantal, so the cosecant of 90 is going to be, the value is going to be 1. So 90 degrees is coterminal with negative 270 degrees. Well, this concludes our work on coterminal angles. Our next segment, we will talk about reference angles. And we will repeat some of the stuff. And looking forward to talking to you. Looking forward to you to tuning in to the Daniel Fritz Mathematics, the professor. And we'll see you tomorrow.